Bubble sorts. So today, this video is going to talk about bubble sorts, and we're going to show an example and explain what it is, and also work with our dragons and use BubbleSort to put something in order. Now, bubble sorts is very simple. You have to make multiple passes through the same set of data, and each time you go through the data, you compare two items. And the reason it's called a bubble sort is every pass you're either, depending upon how you're doing your comparison, you're either bubbling up or bubbling down your elements. So I like visual representations so that we could easily see how something's working. So I just have 5 cards here. And so a bubble sort is like one of the most basic models of sorting. And it will tell you 30 years ago when I went through learning programming, it is exactly the sorting method algorithm that I was taught. And so what bubble sort is you just take two elements, you start at 0, and you take two elements and you compare those two elements. So we're going to compare the 4 and the 1. We're just going to call this 1. And is 4 less than 1? It is not. So what we're going to do is we're going to put the 4 in a temporary spot. We're going to move the A into that spot, and then we're going to move the 4 back into that spot. And then we're going to go to the next two. Are 4 and 5 in good order? Oh, they are. So we're going to say we're going to leave them where they are. We're going to go to look at the next two. Is 5 and 3? Are those in, is 5 less than 3? No, it's not. So we're going to say 5 off into this spot. We're going to move 3 into that position, and we're going to put 5 back in. And now we're going to go to the last one. And now we're going to say, is 5 and 2 in the correct order? No, it's not. We're going to move 5 out, put 2 in, and move 5 back. Now, we've got that 5 has basically made it through the whole entire thing, and it's bubbled up into the top position. So now it's always going to be we're not going to have to check that position anymore. So now the next time through, we're going to go back to the beginning, and we're going to say, look at ace and 4. Are they in the correct order? Yes, they are. We're going to move to the next one. 4 and 3, are they in the correct order? No, they're not. So we're going to swap them out. And then 4 and 2, are they in the correct order? No, they're not. So we're going to swap them out. And now we're done, right? We don't have to do 4 and 5 because we know 5 is already in the correct position. And so now we're going to come back, and now we know 4 is in the correct position, so we don't have to do that one. And so those are in the right order. 3 and 2. Those are not, so we're going to put those in. And now the 3 is in the right spot, right? Because we didn't have to check the last 2. And then we'd have one more check of ace and 2. Those are in the correct spot. So we're done. So that's what bubble sort is basically you're looking at two adjacent numbers. You're comparing them. If they're in correct order, you leave them alone. If they're not, you swap them. And you can stop where you don't have to go check the highest value anymore because you're bubbling up the highest number through all of the cards or all of the spots to that. So now we're going to go do that and actually do it in code. And I'm going to make these into functions. So I'm going to come over into my header file and make my void bubble. And we'll sort by name. And so we'll pass in dragon and then the array and the int count, right? And I'm just going to copy this and go into my implementation file and go find a spot where I could implement this. And so we're passing in dragon. So now we have our array of Ds. And so we're going to do a for loop, right? So you can see that basically our bubble sort is going to be 2 sets of for loops. So we're going to say int I equals 0 while I is less than count and I plus plus. And then we're going to need another for loop for the inner loop. So at j equals 0, while j is less than count. And then we're going to say j plus plus. And to be honest, we don't need to go all the way to count. We're going to do -1. And the reason why we're going to do -1 is we're going to, right, if we go and look at the thing again, right, the first time through, we're going through all of these, and then we're going to go from 5 through 4, or 1 through 4, and then 1 through 3, and then 1 through 2, right? So it's each time is going to go less, so we're also going to need to have it be minus I, -1. Since we're going to be comparing the two next to each other. To compare two items, right, we're going to compare, use an if statement. If D, and then we have J, right, dot name, and we're going to compare if that's less than D J plus 1 dot name, right? So that's what we were doing, and I have got in the habit of typing too many arrows. So, right, so that is, if we go and look at our example with our cards, right, that is basically this, doing this position and this position. So we're comparing the first two positions. And now, if that's false, right, then what we need to do is we need to save this spot into one thing. So we need to swap these two items. Now, we could try to save off all the items, right? I could say, like, I have a string name. So we'll call it dname. And we could do d.j.name. But then we'd also have to do int d level, right? And equals d.j sub level. And we'd have to go and find all the pieces to it and make sure that we got all the levels. But that'd be kind of painful. But all we actually have to do is instead, we're just going to make a new dragon called temp. And we're going to set that equal to the dragon, or the d dot, or d sub I, or sub j. And then we're going to say d sub j equals d sub j plus 1. And then d sub j plus 1 is going to, and I missed the 1 here, is going to equal the temp. And so that, in essence, is swapping the two things, and it swaps all of the members and all of the stuff that's associated with both of those back and forth. So now we need to come back over here, and we're going to print out our dragon, or our list, right? So because we already printed it out once, right? So we want to sort it and then print it. So we're gonna bubble sort, where did I call it? You know, I can't remember things. Bubble name, and then we're passing in the dragons and 5 as the count, and then we'll print out the same list again. Dragons, count. Let's see how we did. So you can see this is the first time around. We have Toothless, Stormy Meat, Windshear, Cloud Jumper. And then we have Windshear, Toothless, Stormfly, Meat Lug, and Cloud Jumper. Now you can notice that they're not in the same order, but it's not in ascending order. Did you notice that? I put it in descending order. So the easy way to switch that if you want it in ascending order is we're just going to go back to our function here, and we're going to swap our greater than or equal sign, and then save and run it again. And now instead of being going from descending order, now it's in ascending order, right? Cloud jumper meet stormfly, toothless, windsurfer. So you can see how you could do the exact same thing, but instead of comparing the names, you could compare the levels, and it would do the exact same thing. So that is BubbleSort. I will tell you, BubbleSort is not the most efficient sorting algorithm out there. If you take a data structures class, you'll go through a lot better options. This is just showing you one sort method that you could do to put your items in a sorted order. And so now if I went to go look for meat lug, it's going to be easier to find meat lug. There's algorithms that you could put in to find meat lug. And so I'm going to show you in the next video using binary search on how to find that.